Hello, everyone. So this is section 6.6. Uh, okay, so before I start the lecture, the web assigned homework, there are like two due dates. One, I've already mentioned 6.2 and 6.3, which is going to be due this coming Saturday, which is November 14. Now, 6.4 and 6.6, since your exam is on Thursday, next Thursday, on November 19, that's why the due for these two sections are going to be on Wednesday. All right. And also, I'm going to, well, on exam 2, I will be covering till section 6.6. So starting from section 5.4 to 6 and 6.6 will be an exam 2. Okay. So, okay, so all right, so this is section 6.6, which is, okay, first I'm going to talk about the derivative of inverse trigonometric functions. So inverse function is, well, I've talked about the inverse means the way we write the inverse is like this, right? So this means the inverse, or we can even say ARC sine of x. So this also means ARC also means inverse, or ARC means arc sine or sine inverse x. Basically, these two mean same thing. All right. Okay, so now first I'll be talking about the derivative, and then I'll be talking about the integration. All right. So the first one, well, all of these things here I've shown here is a formula, right? So when we take the derivative of sine inverse of x, or you can even write arc sine, anything. So the derivative of this one is this. Similarly for cosine inverse is this. Sine inverse, cosine inverse, tan inverse, cosec inverse, secant inverse, and cotangent inverse. Uh, the derivative of all of these are here. All right, so this is the derivative. Okay, so based on this formula, let's do some examples. So the first one, okay, so let's say this is given 1 over sine inverse of x. All right, so how do we find the derivative of this one? Make sure that, well, I see that some of the students, what they do here is they do like this. They take the inverse of 1 and, sorry, they take the derivative of 1 and the derivative of sine inverse of like this. Well, this is not correct. This is wrong. All right. So it's basically, well, if you remember what we did all the way back in the derivative section, I think in section or chapter 2. So what we're going to do here is, well, I can write, well, we know the formula of sine inverse of x, right? But we don't know 1 over sine inverse x. So what we can do here with this one is, well, let's say if we have x 1 over x square, then if I move this to the top, it will be x to the power -2, right? Similarly here, on the power, it's always 1. So if I move this to the top, it's sine inverse of x -1, right? So now after this, I can now take the derivative. So if I take the derivative now, so now I gotta take the derivative of the whole thing. So I gotta put, well, I gotta bring this. So if I bring this -1 here, it will be -1 sine inverse of x and -1, -1, right? Using power rule. And then after that, the derivative of this inside part, sine inverse of x, using chain rule, the derivative of sine inverse of x is, well, we know that, right? So that is Well, we know that, right? So which is 1 over square root of 1 minus, oops, 1 minus x squared, right? So, okay, now let's, well, this one is also, I don't have to write -1 here again, it's just negative. So sine inverse of x to the power -2, 1 over square root of 1 minus x squared. So if I move this to the bottom, it will be, well, on the top we still have this negative, or we can just write -1 over, if I move this to the bottom, it will be positive 2 on the top, and 1 minus x squared, or square root of 1 minus x squared, right? So this is the derivative. This is the final answer, or this is the derivative of this function. Well, our original function was this, right? Yeah. Okay. That's one example. Let me do another example. See if we have y is equal to x. Well, let me just write arc sine of x. So this also means x times sine inverse of x, right? All right, so if I take the derivative of this one, then here I can use now a product rule, right? So we are still using the same technique that we learned back in chapter 2. Well, the technique, there is nothing, well, we are not learning any new technique. It's just that we're using the same technique, but we just that we're introducing some new formulas, and using these formulas uh, and using the technique that we learn, we are finding the derivative, right? So, okay, so now I can, first I can take, using the product rule, I can take the derivative of x, which will be just 1. And this one, the second one will stay the same. Plus, now x will stay there. And if I take the derivative of the second one, it will be, what is the derivative of sine inverse of x? Well, it's 1 over square root of 1 minus x squared, right? So pretty much, yeah, that's it. So just write it in a better way. So sine inverse of x plus x over square root of 1 minus x squared. All right, so this is the derivative. Okay. Now, what about for something like this? Well, here again, we need to use the chain rule. So if I take the derivative of this one, well, first, well, we know the derivative of just sine is 1 over 1 minus x squared, right? Well, here, the derivative of sine inverse of x is this, right? But instead of x, now we have this whole thing 2x plus 1. All right, so that means when I write the derivative, it will be 1 over square root of 1 minus, now instead of x, since there is an x here, that's why we have x here. But instead of x, now we have this whole thing 2x plus 1. So that's why here it will be, instead of this x, well, we're going to replace this x by this whole thing 2x plus 1. And still have this square, so we got to take the square of this whole thing. Okay? And then what we're going to do after that? Using chain rule, we still need to take the derivative of this inside part, 2x plus 1. So if I take the derivative of 2x, it will be just 2. And the derivative of 1 is 0, so we don't have to write that, right? So after this, well, what we can do after this? 2 over, well, let's just expand this. So 1 minus, well, 2x, well, we know that a plus b whole square is a square plus 2ab plus b square. So that's why a here is 2x, b is 1. So using this formula, so it will be 4x squared plus 4x plus 1, right? Okay, so and we gotta distribute this to all of that, so it will give us square root of 1 minus 4x squared minus 4x minus 1, right? When you distribute this negative to all of that, so we will get, well, this is gone, and we'll have negative 4x squared, negative 4x. Well, I'm doing lots of algebra here. So here, now I can factor out 4, right? So if I factor out 4, it will be square root of 4 minus 2x squared, oops, no, minus x squared minus x. So from here, I can, the square root of 4 will be 2. So 2 over 2 square root of negative x squared minus x. Well, this will be gone. So it will be just 1 over a square root of negative x squared, negative x. There you go. So this is the final answer. All right. So yeah, there are a bunch of algebra. All right. Okay. Now, let me do one more example for derivative part, and then I'll start integration. Okay. So okay, so now if I'm taking the derivative of this one, okay, so again, arctangent of this derivative, sorry, the square root of x, well, I can even write this as x times tan inverse of square root of x, right? So then after this, I can take the derivative. Okay, so the derivative here, first, if I take the derivative of just x, it will be just 1 times the second one will stay the same, plus, now x will stay there. Now if I take the derivative of tan inverse of x squared, then, well, we know that the derivative of tan inverse of x is 1 over 1 plus x squared, right? But instead of x, now I have the square root of x, so that means it will be 1 over 1 plus, instead of x, we have square root of x, so it's square root of x, and still have the square, so I gotta take the square of this whole thing. All right, so are we done? Or we still gotta take the derivative? Well, using chain rule, after that, we still need to take the derivative of the square root of x as well, right? So this, the derivative of square root of x, well, we know that x square root of x is also x to the power 1/2, right? So that means if I take the derivative of x to the power 1/2, then I gotta bring 1/2 here, and x to the power 1/2 minus 1. All right, so let me do this. Let me assign this. Okay, so after this, do all those algebra, combine this, move that to the bottom, just rearrange your answer and write your answer and simplify as much as you can. Simplify, maybe you can cancel the x and the square root of x on the bottom, something like that. So simplify your answer and give me the final answer. All right, so you write the final answer, just simplify it. It's just that you got to do a few algebra. All right, So this will be the quiz. All right, so I think I have an assigned quiz in a while. So I know, like I said before, the quiz is basically to see whether you're watching the videos or not. Uh, I don't assign any difficult problem in the quiz. All right, so yeah, just do this. So since this is Thursday lecture, so the quiz is due on Friday, right? Tomorrow. Okay. Now let's move on to the integration. So as I said that, well, the derivative of sine inverse of x is equals to the derivative of this one is equals to 1 over square root of 1 minus x squared, right? So the derivative. But what about if we go to the opposite way? So if I take the integration of this one, 1 over square root of 1 minus x squared, then it will be sine inverse of x, right? And plus c. When you take the integration, yeah. If there is nothing defined here, if there are no interval, then we have to write plus c, right? So yeah, just that we have to go the opposite way. All right. Now, based on this, basically we just need to know whatever formula I mentioned here. Just that we're going opposite way. Now, based on that, now let's do some examples. So first one, let's do this one. The integration of 1 over square root of 1 minus 4x squared dx. All right, so now this one looks similar to the derivative of sine inverse of x, which is 1 over square root of 1 minus x squared, right? Okay, so so the thing is here, it looks similar to that. Okay, so now what we can do with this one is, now instead of writing 4x squared, we can even write this as, well, 4, I can also write 2 squared, and we still have this x squared, or we can simply write this 2x squared, right? 1 minus 2x whole square dx. But now when we compare this with this formula here, here we just have x, but we have this 2 extra. Okay, so when you're taking the integration, we have to get rid of this extra thing. Okay, so now we just need one variable here. All right. So let's do the substitution thing. I think I have mentioned, I've talked about the u substitution and the integration on 6.2 or 1, something like that. So u substitution, right? So what we're going to do is we're going to substitute some of these, some part of this equation by u or anything. You can even say any other variable. Normally, in calculus they use u, so that's why it is called u substitution. So let's substitute this by 2x by u. So let's, if I say that is u, then I can replace this by u, right? So that means it will be similar to that. It's just that the variable is different, right? If the variable is different, it doesn't make difference. It doesn't matter. Okay. I think I forgot to write dx here. Somehow I remember that I made a mistake here. That's why I just want to make a correction. Anyway, yeah, and I can even write u here. If it is u here, it will be u here. It's just that I'm just saying, okay, now here I'm just saying 2x as u. So now after this, if I take the derivative of u, or du over dx, if I take the derivative of u in terms of x, then here if I take the derivative of this one, it will be just It will be just 2, right? So I can replace, well, I'm replacing this by u. So that means I have to change this dx to du as well. So what I'm going to do here is find a dx from here. So if I move this, or if I multiply dx on both sides, then I will get 2 times dx, and then divide 2 on both sides. So dx is 1/2 du, right? So then, um, now finally, now we can get a new integration from here. So the new integration from here, it will be integration of 1 over square root of 1 minus, so we said that 2x is u, so u, we still have the square, dx is, we just got dx is 1 over 2 du. All right, so this 1 over 2 is a number, so I can bring that here. We can bring this outside the integration. So that way we'll just have 1 over square root of 1 minus u squared du, right? So now this is similar to, well, this is exactly same. It's just that now we have u here. It doesn't make difference, okay? So if we have u here, then that means our the integration of this 1 over square root of 1 minus u squared will be sine inverse of u, all right? And of course, after this, we have to write plus c. But since, well, since our original equation is in terms of x, so we have to change this to x. All right, so our final answer should be in terms of x. So also, well, yeah, now what we can do here is we can just replace this u back to x, which is 2x, right? So that means final answer is going to be 1/2 sine inverse of 2x plus c. Right? So yeah, this is the final answer. Okay. Okay, let me do one final example. One more example. Okay, so this one is integration of 1 over x squared plus a squared dx. The square is not clear. Okay, now x squared plus, okay, so we have plus here. So this is similar to, if you go all the way back here to the formula, so if we have plus here, nothing negative here. If there is a negative, then it could be similar to cotangent, but there is no negative in our problem. So it's similar to this one, right? Tangent. So so we can say that, okay, this is, well, our final answer is going to be something tangent inverse something, but at least we know that this is similar to the derivative of this tangent inverse, a tan inverse, right? So which is 1 over x squared plus 1, right? So but we have 1 here, we have a squared here, and on here we just did x squared. Okay, now what we can do with this one is, well, using the algebra. Okay, so we will be using lots of algebra. So using algebra, well, if I just, well, what I can do here is, let's just write a squared outside these two terms, and then let's just say x squared over a squared plus 1. Right? Can I do this? Well, yes. I mean, if I distribute this to these two terms, well, if I distribute here a squared and a squared, this will be canceled, so we'll just have x squared. Okay, so if I distribute this one here, it will be a squared times x squared over a squared, right? If I distribute this to this, I'll get this, right? And again, if I distribute this to here, it will be a squared. So this will be cancelled. So x squared plus a squared, right? So that means these two are exactly the same thing. Okay. Now, well, now a square here, we are saying the a square, a is a constant. All right, so this will be given, um, all right, a is a constant that's given. So since a is a constant, then the a is just some number, so I can again bring this down, or sorry, bring this outside the integration. Okay, so that means now I have x squared over a squared plus 1 dx. Okay, so now, well, we're looking for 1. Well, we got 1. Okay, so that's good. At least we got something. Now, well, we have x squared, but we have a squared here on the bottom, right? So, well, instead of writing x squared over a squared, I can even write this x over a whole square, right? Because it has same square, so I can just combine this to a single square, right? Okay, so now what I can do is, well, since we are looking x square or something u square, some variable. So what I can do, just like I did before, just replace this x over a by some variable or by u using u substitution. Let's just assume let's say u is equals to x over a. Okay, so that means it will be similar to this, right? Now, if I'm replacing this x over a by u, then that means I should also have this dx, well, du, not dx. So we should have du here. So what we can do is, okay, now then let's take the derivative here. So that way I will be getting du from there. So du over dx is equals to, so if I take the derivative of this one, well, this is just a constant, so x over a. So if I take the derivative of, it's just like x over 2. What is the derivative of x over 2? It will be just 1 over 2, right? Similarly, so the derivative of x over a will be just 1 over a. So now I need to find something to replace this dx. So from here, I can get, okay, so multiply a on both sides. So a will go here. Multiply dx on both sides. So dx will come here. So that way I get the dx, right? Okay, so now let me do it in another page. So from there, one over a square right? This is what we have here. This is what I exactly wrote that here. Okay, now, well, we don't need to really worry about this. Okay, so we just assume that x over a is u, right? So x over a is u. Still have the square plus 1 dx is a times u du, a times du. Similarly, I can bring this a outside, so a over a square, 1 over du square plus 1 du. Okay, so from here, these two are gone. Well, basically a is gone, so we're just gonna have a on the bottom. Okay, now this is now similar to tan inverse of x. Well, if I take the derivative of this one, we get 1 over x squared plus 1. But instead of x, we have u. These are just the variable. So that means I can say that the derivative, the integration of this one is tan inverse of u, right? Plus c. Now I gotta replace this u again by x over a, right? So since our final answer is in terms of x, sorry, our original equation is in terms of x, so that's why. So we said u is x over a, so u is x over a, so that means tan inverse of x over a plus c, and that's it. Okay. Yeah, that's all I want to talk about from. Yeah, that's all I want to talk about from this section. So here well, basically the examples I showed here is indefinite interval. So you might, on the homework, you might see some interval, but well, you know the technique, right? I've already shown this technique all the way back in integration section. It's just that you just got to follow the similar technique, but uh, instead of plus c, you will have an interval. So you will be replacing those values to get the answers, right? Anyway, uh, so if I've assigned anything in this video, please make sure you do that quiz, submit that quiz by tomorrow, Friday. Uh, all right, and I will I will upload or I'll email you guys the exam 4 review, uh, definitely by this weekend, maybe Friday or Saturday. All right. Okay. Thank you.